Good afternoon, everyone. This is Mike Romella here with the Hurricane Outlook and discussion for November 19th, 2020, recorded around 3 p.m. Eastern Time. Well, taking a wide look across the tropical Atlantic this afternoon, we don't have really much going on. We have the remnant circulation of what once was Hurricane Iota, which was out here, now kind of spiraling away in the eastern Pacific. But this was a very deadly Category 5 hurricane that came through Providencia and came through portions of Nicaragua and Honduras in Central America, caused extreme devastation there, and has moved over El Salvador and now into the eastern Pacific, where it is dwindling. The mid level circulation is now dwindling away here with time. We do have one tropical wave worth keeping an eye on over the next several days, coming off at a fairly low latitude here. So this will probably end up running into portions of South America, but this could bring some heavy rainfall for portions of South America and then in towards Venezuela and portions of those regions over the next several days. And then we also have two other areas to monitor here in the Atlantic Basin, which we'll talk about here in just a moment. Now, if we look here in the East Pacific Basin real quick, this is now the remnant circulation of what once was tropical storm. It was tropical storm Polo, I think it was Polo. Yeah, tropical storm Polo. Can't speak today. But this was the tropical storm that was very short lived. You can see the remnant circulation here, still a closed circulation, in fact, but devoid of little convection at the moment because of strong upper level wind. You can also see these cumulus clouds over here. This is not an indication of instability in the upper levels. This is actually a signal of cold air. What's basically happening here is you've got really cold air rushing down, and you've got a steep lapse rate in the very surface here. You got a pretty steep lapse rate at the surface, but just up above the surface, you've got a cap in the atmosphere, and we talk about that cap in severe weather terms. But we also refer to this as a temperature inversion. There's a very steep temperature inversion up here, so you're getting a cold core cumulus set up out here, and also some alto cumulus. But other than that, this is a dwindling circulation, strong upper level wind, dry air, and just generally unfavorable conditions prevail across the eastern Pacific basin. Now, on the Atlantic side here, we do have two areas to really watch. We're really down to one area. This no longer really exists, a 0% chance over the next 5 days. Will bring some showers and thunderstorms to portions of Panama and Costa Rica over the next several days, but not really a threat for any tropical development. And then we are also watching an area anywhere from the Bahamas towards Bermuda for an area of potential subtropical development over the next 5 days. This will generally skirt northward with time, so not really expecting any significant threat from that. And one of the reasons mainly for this is because we have, you can see here on the Kelvin wave forecast. This is the convectively coupled Kelvin wave map, and again, we've talked about this very briefly in the beginning of the season and closer into when things were starting to get active. So a little refresh on what we're actually looking at here. You've got the blue colors indicate a favorable convectively coupled Kelvin wave. This enhances rising air in the atmosphere. So all this rising air is kind of passing over this area right now. And you can see that very clearly here on the visible satellite, that we have all of the shower and thunderstorm activity out here. And we also have still some pretty active weather along the stalled frontal boundary right across here. And everywhere generally in this area is relatively active except for out here, big plume of Saharan air and dry air out there. But generally, we have this active phase of the Kelvin wave that is going to be passing over Africa here over the next several days. You can see the oranges here. These are your suppressed phase of Kelvin waves, so they typically suppress hurricane development. And this convectively coupled Kelvin wave will be moving over Africa, but at the very same time, you can see another suppressed phase of the Kelvin wave will be rapidly moving in behind this active phase. So this should be really shutting down and capping anything out down here across the central Atlantic and the Western Caribbean. Now, again, though, this may help to spiral some extratropical systems, maybe a subtropical storm out here in the North Atlantic. It should be north of Bermuda, or should be really north and east of the Bahamas, and could be near Bermuda. But again, We don't know if that's going to be an actual system or whether this would just be some mid-latitude cyclone, which is looking a little bit more likely at this point. So we can see here on the GFS forecast, this is the 700 to 400 millibar relative humidity product. And what we're really looking at here is the wide shot of the whole entire North American continent and really the Atlantic basin here and part of the Eastern Pacific, which is over here. So you've got a lot of dry air right now. This is generally what we've been talking about, some mid-latitude energy here near the Azores and the Canary Islands at this moment. There is the Cabo Verde Islands right there, and here's the Lesser Antilles. Again, you can see that we have a little bit tongue of moisture. This is along that stalled frontal boundary that you can clearly see. And again, you can kind of see where the transition zone is. We actually pop a sounding here. And this is something that we can do here. If we pop a sounding, this is out in front of the cold front here. So out in front of this region, you can see what we have is a fairly tropical air mass. This is the GFS forecast sounding for 12 hours from now by 7 p.m. this evening. You can see a fairly weak to moderate lapse rate, the moderately positive lapse rate, I should say. You can see that the temperature is actually decreasing with height, as we would expect. And if you followed us on Twitter, you'll hear me talk about sometimes a temperature inversion, which we'll talk about here in a moment. But you can see we have a weekly positive lapse rate, so this would be semi-conducive for thunderstorms out in front of this environment. There's relatively decent moisture all the way up here, at least into the about 700 millibar range of the atmosphere. And then after that point, you can start to see they're becoming an elevated mixed layer in here. This is where we really start to cave out a lot of dry air in the mid-levels out here. And this was a response into some mid-latitude subsidence caused by some of this mid-latitude dry air that's out here. So we've got some dry air in about the 450 to, or really about the 350, all the way down to roughly about the 700 and 650 millibar range of the atmosphere. And then up above that, we also have some fairly moist air above that as well. But if we take a sounding back here in the dry air environment, this is behind the cold front, what you'll notice is a different story. Instead of what we were looking at the first time, yes, you still have this is actually a fairly steep positive lapse rate in the first couple of kilometers. This is up to right about 800 millibars or so in the atmosphere. So this is, about 3 to 4,000 feet. This is closing in there at about 5,000 feet above the ground there. After that time, you actually see the red temperature line. This is what the red line indicates is the red, this is temperature, and in degrees Celsius. And you can actually see that the temperature goes up here and it warms quite substantially. So if you kind of take that down here, you get almost about 30 Celsius. You get about a 30 Celsius temperature there at, what is this, roughly at about 850 to 700 millibars. So this is known as a temperature inversion because we are now, you can see that the homogeneous cool air, I mean, it's not really cool, it's 72 degrees, but the homogeneous cool air down here is right there, and up above that is all the rest of the tropical energy. This is, this right here is the transition zone, and up above that is the actual front itself. And you can see a lot of mid-latitude subsidence. This is caused actually primarily by drying of the atmosphere. So this is actually also a dry air inversion as well, because you get a fairly substantial subsidence region in here as well. So with that being said, if we kind of continue this forward here, this is going out for the next about 84 hours or so. Here's our system trying to develop out here in the subtropical Atlantic. So if we take a sounding out here in the moist air environment, we can see that what we've actually got here is a fairly, we don't have a decent lapse rate. It's a moderately, it's kind of a moderate positive lapse rate. In this environment, you can see fairly significant PWatt values. The precipitable water, this basically indicates what how much moisture you can wring out of a thunderstorm in that environment. So you have some pretty good moisture there, but you also have some vertical wind shear in that environment as well. And the GFS doesn't really spin it up at all. It actually kind of spins up something in the mid-latitude energy way up in here. We can actually take a look at that in the homogeneous air environment. That's actually a contaminated sounding. So we'll jump out here a little bit more. You can see that we have, again, this very sharp lapse right here, a temperature inversion out across here, and then a weak positive lapse rate, very dry air, so another mixing layer situation in that case. Now, if we look actually out here at the cyclonic potential vorticity. This is something we're kind of getting away from the tropics here because there's not a lot to talk about. But in terms of the lower 48 weather, you can see here by midweek, we'll actually have the potential for a cold front to be developing out here. So if we actually look here, this is a vertical cross section, and this basically goes from all the way up north here in Montana, all the way down towards Florida. So we have a fairly significant range here of distribution. So you can see up here, this is basically, we'll highlight this in blue, this is basically the stratosphere, and this is basically the atmosphere all down in here. So what you're going to be looking for here is over the next couple of days, what you're going to be looking for here is all of this, all of this kind of red and orange colors to actually dip down. Now, normally, what you're supposed to see is all these red colors and these contours that are supposed to be up here in the 500 or in the 100 to 200 kilometer layer of the or millibar layer of the atmosphere. So they're all supposed to be up there. Below that, you're supposed to have generally all blue colors. Now, if you kind of move this out here, we can see this is by hour 120. You can see here a vertical cross section now. You can see what's starting to happen. All of this homogeneous air that's out towards the north here, this is kind of looking generally towards the northwest, and that's towards the southeast. You can see that what we're getting here is a lot of this air in the upper tropopause here to actually get pulled down here. And you can kind of follow this around and make out a cyclonic vorticity area in here. And you can infer this is the area of low pressure. And we can also infer that there's a front that is kind of draped across this environment. If you look at the close, the close packing here, you'll notice that you can start to see something of a front that is sort of draped something like that. So you kind of have a front that is draped across here, and you can actually see that here as well, kind of a front that's draped across here. And if we continue to move this out forward with time, you'll actually see what happens here. A lot of this on the back side here, you get a lot of transport that's coming down on the back side of this, and a lot of upward moving air on the front side of this. So you're kind of getting the transport of very cool air on the back side, very warm air coming up on the north side, and you can kind of infer that you've got a front. The front is located somewhere roughly in about here, and you have kind of your warm front that is sort of like that. So that's kind of our warm front area right there, extending all the way down there. So this would kind of convert here to something that you have a cold front approaching the plains here and a warm front that is draped really across the Ohio Valley region like that. So that is really how to depict kind of where our fronts are. And if we actually look here back on the GFS forecast, this is for the eastern United States. And what we're looking at here is hour 102. So this is kind of at the very start of the forecast time. This is hour 102 here. You'll notice that we have a fairly, not a zonal flow, but you can see here that we have a relatively light flow across most of the eastern United States right now. However, you notice what's going on out here across the Rockies, very tight isobar packing. So this is indicating that we have some type of disturbance that is forming. And indeed, you can see that on the lee side here, what's called lee cyclogenesis, on the lee side here of the Colorado Rockies, you're going to start to get this area of low pressure that ends up developing and skirting off towards the north and east. This is going to promote a very strong front. This is called frontogenesis that is going to occur across this area. So this is our 108, our 114, our 120. Now you can see this area of low pressure approaching into Iowa right now. You have a trailing front. Now, to really see the fronts here, what you're going to want to do here is actually look here at the 2-meter dew point. Actually, we can switch this to the 2-meter temperature, and this will kind of give us a better scale here. Now, one thing for depicting cold fronts, you always are going to have your cold front in the front side here, kind of right along this transition zone, not behind the transition zone and not in the cool air. It's always going to be in the warm air sector is where the change of front is, where the change of dynamics are. So you have your front that is positioned something right along like that. That's our cold front. You've got your warm front that's kind of extending something like that. Now you can see here that we have a very strong temperature advection. And to look at this in a better sense here, we'll look at the soundings for our this is our 132 here. So this is taking right on kind of the tri-state border between portions of Missouri, Kentucky, and Illinois there. And that you can see here is a fairly moist sounding. Again, this is not necessarily one of those soundings that is going to scream severe weather, but you can definitely see a very sharp southerly advection down here. The wind barbs here are blowing from the north to the south, so we have a south wind, and that picks up fairly quickly to about 15 to 20 knots, even some 25 knots there out of the south-southwest, just above the surface. So you have a very strong temperature advection here in warm air advection. So you can actually see that 62 Fahrenheit at the surface, 54 dew point here. And again, you don't have a fairly sharp lapse rate. It's actually kind of just a weak lapse rate in this region, a weakly positive lapse rate, which is the temperature is slowly decreasing with height there. Again, you have a very moist air mass out in front of it. So this is a very moist air mass. Now, if we look for this exact same time, this is behind the front, you'll see a much different story here. This is 47 degrees here and a 29 degree dew point. So you can see there's a fairly significant temperature and dew point deficit here. And you can see that just above the surface, the temperature actually warms quite substantially, then cools again, then warms, and then finally kind of cools. And you follow up along a moderate lapse rate all the way to about 400 millibars, then all the way up into the tropopause. You can actually see here that you have some very strong north winds here coming out of the north-northwest, kind of turning basically almost due north here at about the 800 millibar range. So this is very indicative of a front in this region. We can look here at the maps from Pivotal Weather. This is our 120. So you can already see this very strong warm air advection that is taking place out here. You can see very strong warm air advection. This is the warm air coming into the Great Plains. So you could actually maybe see the potential for some showers and thunderstorms out across the Great Plains areas here by 5 days from now. Now, if we continue to move this forward, you can see this very strong warm air advection, warm air approaching really in the almost the upper 70s here. The mid 60s, upper 60s to low 70s is very sharp warm air advection, although it's not substantially warm. We can see the 50s across portions of Indiana. Our front here, we'll kind of draw out the fronts for you. This is kind of our front area right there. And you can kind of have your warm front that's kind of draped something like that. So that's kind of where the advection is going to be. And you can see that rapidly starts to clear. Then we have our trailing front. Now, what's going to start to happen here is you're going to start getting an occlusion process. So our front is actually something much like this now. And you can kind of carry that there. We have kind of a warm front that is kind of draped something along that. And then we also have our occlusion process that is getting ready to kind of take place out like that. So that's going to be kind of the subnoptic scale setup by then, and then that starts to occlude. You can see the cold front now has kind of basically been occluded from this environment. Your warm front is actually generally positioned to the north, and then you have your kind of occluded area, your occluded zone back and through here. So that's kind of your occlusion process there. So that is how to pick up the fronts, and that is kind of the exits for today's video. Hope you all have a great rest of your afternoon evening. Of course, I am Michael O'Malley. I'll talk to you guys again some more tomorrow.